Hi everybody, we are going to move on and we're going to do the type of method that is probably in all the textbooks and that most physics professors use. This is what I refer to as the traditional method of circuit analysis. So it's the one that you'd probably been reading in Coletta on chapter 18. If you're in physics 112 and 131, 101 students probably shouldn't do this. It's a little complex. But for sure, if you would like to attempt it, that'd be fine. So you will probably be using this a lot in your homework 7 circuits and sapling, but also your just circuits lab in physics 112 and sapling. So to do this, there's quite a few steps, and this is a good method to use if you have to program something in to a computer or to a spreadsheet. All right. And there is a consistent method and procedure to follow. So I'm going to go ahead and list it off here, and then we'll go through and try an easy circuit, and then we'll try just an easy one loop, then we'll add another loop and then another loop, and then it'll get more complex from there. Okay. So what the first thing that you're supposed to do is you're supposed to identify just like we've always done, is try to track the current's flow across all branches and in and out of each junction. But what you're also going to do is draw little arrows for what you think the current is flowing across each component, including the batteries. A lot of these things that we're going to be using are going to actually have 2 batteries in the system. So we're going to have to, sometimes it's not clear. You're going to have to make a guess at which way you think the current is flowing. Okay? And then after you track the current across all components, across the junctions, across everything, your best guess, what you're going to then do is you need an accounting method. And you're going to draw a loop to account for each component. And the loop is going to be clockwise or counterclockwise. And so if there are two major loops, then you'll have to draw 2 loops. And I always try to keep my loops in the same direction. So if one loop is clockwise, then I'll keep the other loop clockwise too. All right. Then after you do that, and you need to then start accounting for the components, you're going to focus on one loop at a time. So you're going to do one equation for one loop. You're going to have to pick a starting point, and then you're going to move in the direction of your loop. And then as you're walking across each component, you're going to be adding and subtracting the voltage, the current. So if the current is flowing in the same direction that you're moving, that's going to be a positive current. If it's pointed opposite the direction, it's going to be a negative current. It's going to be a negative. And then what you're going to do is you're going to set your voltages on one side and set that equal to the current times the resistance on the other one. So the best way to do this is to just jump in. All right. So let me summarize those things right now again. We have a battery, so you're given this, and so this is the entire method just all put together. Okay, it's got the final step right here with the equations. You identify the currents at each node, and so basically you're trying to create these equations. On the left side of the equations are the voltages. So there's a 10-volt battery and a 20-volt battery. So notice that there are 10s and 20s. Notice also that they don't put the voltages here. Okay. Notice that there's a 10-ohm resistor, and that's what this is. They don't put the ohms here. So they're not putting the units on things, which some people do, some people don't. It looks cleaner if you don't. So R1 is going to be the 10 ohms. R2 is going to be the 20 ohms, and R3 is going to be the 40 ohms. Okay, so we are going to do this right now. Okay, just a couple things to notice is that so you need a starting point. So I would probably choose this. So we're going to do loop 1 really quick. they've chosen to walk clockwise. They guessed that their current 1 is traveling to the right. When it hits this first node, node A, current 1 is going to join up with current 2 traveling to the left to become current 3. And that means at B, current 1 is going to then travel back to the left, and current 2 is going to travel to the right and split off again. Okay, so starting from here, the battery is pointed up in the same direction that we are moving, so we're going to be moving clockwise around this. So starting right here in this corner, we're going to be moving up. The battery's pointed up, so that's going to be a positive 10 volts. We're moving to the right. Current I1 is pointed to the right in the same direction we're moving across R1, so that is going to be a positive 10 I1. It's going to be positive 10 volts times I1. And now we get to this part, and now we're going to be moving down. We're moving down in the same direction, right? Because we're moving clockwise. We're moving in the same direction that I3 is across R3. So that's going to be a positive right there. Let's try loop 2. Loop 2, they've chosen to be counterclockwise. So loop 2, we're going to start here. We're going to be moving up, and we're going to be moving up in the same direction that the battery. Notice the battery is pointed up. The positive terminal is on top. The bottom is a negative terminal. So that's going to be a positive 20 volts. We're going to be traveling to the left in the same direction that I2 is across the 20 ohm resistor. So that's going to be a positive. Now we're traveling down, and we're going to be traveling down along the same direction that I3 is pointed across the 40 ohm resistor. So it's going to be a positive 40 I3. And then we finish it out and end at our beginning position. They've also done the outside loop, which is called loop 3. Okay. So I'm going to start this outside loop. Okay. I'm going to start right here. I'm moving up in the same direction that the battery is pointed. Positive terminals on top, negative terminals on the bottom. So the battery is pointed up. So it's going to be a negative 20 volts. A positive 10 volts, I mean. Now we're moving to the right in the same direction that I1 is pointed across this 10 ohm resistor. So that's going to be a positive 10 I1. Now we're going to be moving to the right in the opposite direction that I2 is pointed when we get to the 20 ohm resistor. So we're going to be subtracting that off. And now we're going to be traveling down in the opposite direction that the 20 volt battery is pointed, which is going to be a negative 20 volts. Then we come down, there's no components, and we finish it out. So that's how they got this. And now you have to identify your currents in your nodes. Node A is going to be I1 joining up with I2 to equal I3. And then node B is I3 coming down, I1 traveling to the left, leaving, and I2 is traveling to the right and coming back in. All right? So that's how you make these little equations. And so what you would do is you would combine these equations together. So we have, we're going to be trying to identify the currents. So we don't know what I1, I2, and I3 is, but by combining these equations together, and also these other two equations, well, actually this equation, just one of the nodes will work. So you have 1, 2, 3, 4 equations to solve for 3 unknowns. Completely possible to do. Okay? So let's try this out. Let's just try this method with a simple one loop problem. All right? So here we go. I'm going to go ahead and use the markup tool. Okay? Oops, hit the wrong button. Go ahead to comments and close that back. All right? So let's try a markup tool. There's only going to be one current in this. So I'm just going to use our traditional color for current as just red. Okay. Arrow for red. Okay. And I see a 12-volt battery. I see a 2-ohm resistor. Okay. And I see an 8-volt battery pointed in the opposite direction, and I have a 6-volt battery pointed to the right. I am not sure which direction the current is pointed. So I'm going to make a guess that it's going to be traveling this current. I'm going to say this guy right here. I'm going to guess that the current is going to be traveling to the right. So that, I'm guessing the current's going to be traveling to the right. This is a bigger battery than this 8-volt battery. And I might have made a wrong guess. I'm not sure. And so it's going to be the current. And I'm just going to call the current just I. Since there's only one current, I'm going to call it I1. And I shouldn't use symbol. I use courier most of the time, or Calibri. There we go. And I'm going to call this, I'm going to call this current. Okay, come on. So I'm going to call this red current I1. I didn't have to subscript it, but I want to be consistent with everything else. So I'm going to say I1 is, I'm going to guess that since there's only one pipe, there's only one current, there's no junction, so this current isn't going to be splitting up. I1 is going to be traveling to the right across all of these components because this is a big battery. Okay. And then I'm going to also guess that I1 is going to be traveling down this wire, traveling across the 6-volt battery, and it looks like I1 is going to be traveling in the opposite direction. That's going to be interesting. And then finally, traveling up across this bare wire, so notice that I1 is just all over the place. It's just the one current. Okay. All right. Now we have to draw the direction that we're gonna. So we've drawn. So the first step is draw all the currents across each branch, and there's only one current going throughout this one loop. Okay. So now we're going to have to draw an accounting method. So I tend to try to draw in the same direction that my current is flowing. So this current looks like it's flowing counterclockwise. Okay, so I'm going to set up my loop or my accounting method to be going in the same direction. Okay. And that is supposed to look like a loop. Okay. I'm going to redraw that. That is terrible. I'm going to actually use my pen and try it again. So I'm going to say that this guy is going to be counterclockwise. And this is supposed to be an arrow. All right. So here's my accounting method. And now I have to pick a starting point. So I'm going to start right here. And it doesn't matter where you start. I tend to choose corners. So that helps me. Okay. And then what we're going to do is we're going to create an equation down here, and it's going to be V is equal to I times R. And I'm actually going to use the symbols and things like that. Okay, so V is equal to I times R. All right, so I'm starting here. Here's my start point. And I'm going to follow this black arrow. So the black arrow is saying I have to go up, and I'm going to be traveling to the right. So I'm going to be traveling to the right across this 12-volt battery. So this 12-volt battery is pointed to the right, and I'm also moving to the right. So that's going to work out to be a positive 12 volts. And you know what? I'm probably going to, there's a lot of stuff going on here, so I'm going to need a lot of room. So it's going to be positive 12 volts. Okay. Now when I get to the 2 ohm resistor, okay, and I'm going to put that right here. So the currents and resistances go on to the right, all the voltages go on the left. So I1 is traveling to the right, and I'm moving in that same direction. So this is going to be 2 ohms I1. Okay? And I'm going to draw that to look more like an ohm. And I'm actually going to write I1 as in red. And switch black back to black there. All right? Now, if you notice, this battery right here, the 8-volt battery, is pointed to the left, but when I'm following this loop, I'm moving to the right. So I'm moving in opposite directions of that. So that 8-volt battery is opposing me. So it gets subtracted off. Okay? So I'm moving, I'm following this loop. That means I'm moving counterclockwise, well, I'm moving clockwise, and then I get to this 8-volt battery, which is pointed to the left, and I'm moving to the right. That means it gets subtracted off. Now I'm going to continue going down, and I get to this 6-volt battery. Well, I'm traveling to the left. This 6-volt battery is traveling to the right, so I subtract that off. And what we have now is an equation. And the whole point in doing these equations is to get the current. Okay, since you already know the voltage and across each battery, and you know the ohmage here, you have to find the current, and then you could use this side to figure out what the voltage is going through that resistor too as well. So let's go ahead and try to find the voltage and the current, which the current is I1. And we know the current I1 is going across this little guy. So I'm going to call this I1. So we want to find the voltage, current, and across that resistor. Okay? And by the way, that current is the same current going through each one of these batteries as well. Well, 12 minus 8 minus 6. Well, negative 8 minus 6 is going to be negative 14. So 12 volts minus 14 volts is going to be negative 2 volts, right? And then I have a 2 ohm resistor, and then I have a current I1. Well, this is going to be an interesting problem because it's negative 2 volts equals 2 ohms I1. So to find what I1 is equal to, and I started something and I should use red for I1. Okay. Well, now let's find out what I1 is equal to. So I'm going to go ahead and divide negative 2 volts by 2 ohms, divide 2 ohms by both sides, and that is what is going to be equal to our I1. And here is, so I1 is going to be that. Well, what you find out is negative 2 volts divided by 2 ohms is going to be negative 1 amp. Well, you can't get a negative 1 amp, okay? What that means is we wrongly guess the directions of our currents, okay? We assumed, because I assumed actually, that this is a 12 volt battery pointing to the right, and that's greater than the 8 volt battery pointing to the left, that the current was going to be traveling. I assumed that this red current was going to be traveling clockwise around in the circuit. I assumed wrong. So what that means is the current is actually going to be pointed to the left, okay? And you, as soon as you make a bad guess like this, correct it, okay? So this, I'm going to correct it right now. Whoops. By grabbing this. This current, and the current should be traveling the opposite direction. So I'm trying to correct this. Hold on a second. So here you see I've actually corrected the current, and now I've made it so that the current is flowing counterclockwise, okay? And so now we could go ahead and write what our current is across this guy. This is going to be a positive 1 amp. Again, you can't have negative currents. So this is going to be 1 amp. This resistor is 2 ohms. And what that is going to be, what is that going to say? Well, that's going to say 2 ohms times 1 amp is going to be 2 volts across this one resistor. Okay? I'm always suspicious of methods, so I wanted to try this out, okay? To make sure. So I attached this little PHET simulation, and here I'm going to go to it. And here you have is the 12 volt battery, the 2 ohm resistor, the 8 volt battery pointed to the left, the 6 volt battery pointed to the right. So hooking this up, you could see that the current is indeed going counterclockwise. And I'm going to pull out a few tools, the voltmeter and the ammeter, and I'm going to measure that current. And that is, in fact, 1 amp. And I'm going to move this across this one resistor, and that is 2 volts. So the current across this resistor is also 1 amp, and it's 1 amp everywhere. Okay. Current's 1 amp everywhere. It's 1 amp across the resistor, and that works out to be 2 volts. So it looks like our method works out. Just sometimes if you make a bad guess, if it works out to be a negative current, then just basically turn it into a positive current and correct your directions of your currents on your drawing. Okay? So now let's try this in combination with the traditional, with the method that I've shown you in this past bunch of activities. All right? Right now, what I want you to do is you have a 12 volt battery, okay? You have a 2 ohm resistor, you have a 4 ohm resistor, and you have a 3 ohm resistor. go ahead and use the method I've shown you to actually figure out the current voltages and resistances, not using the traditional method, using the method I've shown you, and get it really quick. And what we'll do is we'll double check everything, and we'll do our we'll apply the traditional method to check our old the method that I taught you before. So go ahead and pause the video and try it right now. Okay. All right. Well, here we go. What do we have? So we have 12 volts right here. Okay. So this is a 12-volt battery. And since this branch is in parallel with the 12 volts, we know it's getting 12 volts. And then this top one, R3, is also getting 12 volts. So what we could do is just say this. It's getting 12 volts, right? Because that's the third rule. 12 volts divided by 4 ohms, that is going to be 3 amps. Okay? Right? Well, in this middle branch, we have 2 ohms and 4 ohms that are in series with each other. So 2 ohms plus 4 ohms, that is going to be 6 ohms. And that 6 ohm, so I'm going to imagine these guys are gone, and that you just have one resistor right here that is 6 ohms. And this is on its own branch. These guys are not here. So this is a 6 ohm resistor in parallel with 12 volts. So that means it's going to be getting 12 volts. And that means it's going to be using 2 amps to do that. 12 volts divided by 6 ohms, 2 amps. And so what that tells me is I'm going to remove all those, is that this is 2 amps and that this is 2 amps. Okay? 2 amps times 2 ohms, that's going to be 4 volts. 2 amps times 4 ohms, that is going to be 8 volts. Cool. Now let's talk about our currents. You have a current flowing up here, flowing out of the one battery, and that's I1. You have it's going to be going, another current is going to be going to the right, I2, and that we know that I2 current is 2 amps. And we have another current, so we're going to say that is 2 amps. And we have another current, I3, which is 3 amps. Okay. Well, I1 is traveling into this junction. I2, which is 2 amps, is traveling to the right. I3 is traveling up. That means this is 5 amps. 5 amps going in, 2 amps going to the right, 3 amps going up. So that this guy is 5 amps. So using our earlier method, we can now figure out what a method to check to see if that traditional method is going to work. And this works really well with if you don't have any other batteries in the system. As you can see from our earlier example, I don't know if it's possible to use that traditional, that other method that I've shown you to do this. It looks like the traditional method is about the best way to be very consistently checking your work. Okay? Well, let's go ahead and try it right here. Let's try the traditional method and do the loops and currents for, and this part right here is just this lower part here. So try the traditional method and just do this, okay? So you're going to have to track your currents, you're going to have to track your loops, and do and try to get an equation here. And again, the equation will be in a form of voltage is going to be equal to current times resistance. Okay? So go ahead and try that right here. And hit pause. Okay. Well, let's track the current. I'm going to use red. And try to color code this. I'm thinking that there is a current leaving the battery to the right. So I'm going to actually draw a large current to the right, and that this current is going up, and then it's going to enter a junction, and that junction is going to split into one current and a different type of current. So I'm going to color code those to one current, and I'm thinking that is going to be the I2 current. And then we'll give green the I3 current. That would have been traveling up, but we don't need to draw it right here. Okay, so let's call I3 that, and we'll call up. And we'll call I2 blue to be consistent. And we'll call I1 red. All right. Well, cool. Okay. Well, now we've got, and actually I probably should finish that out. So I'm going to call this I1, and this is I1, and this is I1. So red is I1. Blue, I'm going to call I2. So this is I2 traveling across, and I don't know why I had enough room. I could have just drawn it there. There you go. So blue is traveling across that. Okay. Well, let's start our loop, and I'm going to choose black as our loop. All right, so I'm going to try to keep, it looks like that current as I've traced it is going clockwise. All right, and so I'm trying to be consistent. This is the accounting method, so I'm going to try to be consistent in the way I do that. I have to pick a start position now, so I'm going to start right here. So I'm going to start here, and I'm going to now walk counterclockwise, and I'm going to try to follow the current across each one of these resistors. Okay. So I get here, go to the start. Now I'm traveling to the left, and the battery is also pointed to the left. So that is going to be a positive 12 volts. Okay. Right here, so now I'm going to be traveling up, traveling to the right, and I'm going to be now traveling to the right in the same direction that the current is pointed across this resistor. So that is going to be positive 2 ohms, I2. And then I'm going to continue to move along counterclockwise with my loop, and now I'm going to the right across this I2. So I'm going in the same direction that I2 is pointed. So that's positive 4 ohms I2. Okay, cool. Okay. Well, we've drawn a bunch of cool stuff. Let's go ahead, and that looks complete. And so you can see this is going to be, if I wanted to complete this, and let me do something real quick, because I could just do this for right now. Close. I could actually complete this problem. Okay. So if this is 12 volts, 2 ohms I2 plus 4 ohms I2. Since that's the same current, we can combine that. That becomes 6 ohms I2, which means this I2 is going to be 12 volts divided by 6 ohms, which is going to be equal to 2 amps. So you could easily just do the problem really quickly. Okay. Let's track our currents across the top loop here, this top loop. Okay, let's try to do that. Again, I'm going to be consistent with my earlier drawings. And I've got to track, we've decided here that I2 is traveling to the right across the 2 ohms and 4 ohms. And we're going to do that, and this is going to be I2. Okay. We've said that the current I3 is traveling up here, and it'll be traveling to the right across the 4 ohm guy. All right, and then it'll be traveling down. It'll be then traveling down. Red will be leaving. And blue will be coming in too. Okay, so we're now doing this other junction where blue is coming in. I could, just to make it clear, just draw that red would be coming in here. Blue's going to the right, I3 is going up, and then blue and I3 are combining back again to become I1. Okay, it's not necessary to do that though. All right, so let's draw our direction that we're going to move. Since I went clockwise with this loop, I'm going to go clockwise with this loop here. Okay, so I'm going to go clockwise with this loop, and I'm going to pick my starting point. I like corners. I'm going to start right here. So this is my starting point. Okay, so I'm going to be going clockwise. That means I'm going to be traveling to the right, and I'm going to be traveling to the right in the same direction that I3 is traveling across 4 ohms. So the 4 ohms I3. And then I'm going to be traveling down, and I'm going to get to this point. Now I'm going to be traveling to the left, and I'm going to be traveling to the left in the opposite direction that I2 is pointed for the 4 ohm guy. So that's going to be negative 4 ohms I2. Okay, then I get to here, and now I'm going to be traveling left again against the current I2 across the 2 ohm resistor. So that's 2 ohms I2. Okay, and since there are, and then I'm travel back up to the start across no components. Since there's no batteries here, you just put 0 volts. Okay. Now you could do some things to reduce this down. Okay, you could combine these two resistors. This is negative 4, so 0 volts is going to be equal to 4 ohms I3 minus 6 ohms I2. And you could bring that 6 ohms onto the other side. Okay, and it looks like I'm going to probably need some room, but what I'm going to do, I'm going to say this, is that 6 ohms I2 equals 4 ohms I3. All right. And actually what we've done here, this equation and this equation right here, I've just copied them over here. And you could do one other thing too. there is an outside loop that we could do, okay? But it's not necessary since we've accounted for the first two loops, and since both of our loops are going counterclockwise, clockwise. We have loop A, which is this. We have loop B, which is this. When you add those two, since both the loops are going in the same direction, you could add those two loops together, and what happens is you actually get the outside loop by doing that. Which, if we did that, and we followed the outside loop, it would be 12 volts. We're moving the same direction, so that would be 12 volts is equal to, and then we'd be traveling to the right across the green I3 across the 4 ohm resistor. So that'd be 12 volts equals 4 I3, which is what we have on the next page. I think this is a mistake, and I think I have here. Sorry. Let me do some things here. Let me correct some things so it's consistent with what I've done. I said this was I2, and this is I3, and this is I1, I2, I3, and I1. And so what is that saying? That is saying that I2, 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 and then this outside guy is I3, and this is I3. So what is that saying? That is saying that I2 plus I3 is equal to I1, and this is going to be I2, and this is I3. So I'm sorry about that. That was inconsistent. So here we go. So the outside loop, when I add these two linear equations together, it actually, you got 12 volts plus 0 volts is going to be 12 volts. 2I2 minus 2I2 is 0. So that is going to be 0. 4 plus 4I2 minus 4I2 is going to be 0. And then finally, you have 0 here plus 4I3, which is going to be 4I3. So what you could say is that 12 volts is equal to 4I3, and so I3 is going to be equal to 12 volts divided by 4 ohms is going to be 3 amps. Okay, and so that's how they got that, all right? And then once we know that this is going to be 3 amps, you can combine these two together to get in such a way. So I'm going to rewrite this right over here. I'm going to erase this thing. So I'm going to take loop B, and loop B is 0 volts equals to what is that? Negative 2I2 minus 4I2 plus 4I3. Combine these two together, just like we did before. Negative 6I2 plus 4I3. Bring this onto the other side. 6I2 equals 4I3. Okay. We're going to solve this for I2. I2 is going to be equal to 4 over 6 times I3. And we know I3 is equal to 3 amps. So this is going to be 4 over 6 times 3 amps. And that's going to be 12 divided by 6, which is going to be 2 amps. So now we know I2 is now 2 amps. Okay? And so since in this junction, I1 is coming in, I2 is leaving, and I3 is leaving, so 2 amps plus 3 amps is 5 amps. Okay? And that is a 2-loop problem. Now, what do we do? Let's do the same problem, okay? But let's add a battery right here. Let's add a battery right here, okay? And we're going to do that right here. Let me do something real quick. Now you could actually meld the two methods together, the traditional method that we're learning right now and the method that I taught you earlier. And really quickly just get the current right here. You should do whatever is easiest and clearest to you and do whatever you can to find the currents and the voltages across each resistors as easily as you possibly can and as accurately as you can too. So we could actually cut down a lot of work, right? Since this branch is in parallel with this branch, which is in parallel with this branch, again, then you know that this is 12 volts, right? Because that is rule 3. 12 volts divided by 4 ohms. So that is going to be, 3 amps, right? So even though you have another battery 6 volts worked in here, it still doesn't affect what's happening here. It's kind of crazy. It's a very interesting problem. Okay. So and I could build this in PHE to show you too, to confirm everything that we're doing. But let's go ahead and I want you to try getting this answer using the method that I just did. I got you started right here, and do this loop. Since we did this outside loop, you actually don't need to do this this part. You could actually just do this internal loop, and then we'll have everything. So go ahead and try doing this right here. Identify your currents coming out from the batteries. Identify the direction that you're going to walking, clockwise or counterclockwise, and go ahead and try this part. Hit pause now. Okay, I'm going to do this quite quickly. I'm guessing, again, I'm going to use I1 is coming in. Actually, I'm just going to call that I. I'm going to call this I. We don't need to subscript everything. So I is coming in, I1, and let's try to use colors to color code it. I know I just said that we're not going to do that, but let's do it. So I1 is coming in. No, just I is coming in. Okay, and that means I is traveling to the right there, and I is going to be leaving. Okay, let's use a different color for I2. I'm guessing, I1. Let's say I1 is traveling to the right there, and we're going to use blue for that. And we're going to use green for I2. So I is coming in, I1 is traveling to the right, I2 is traveling up, and then they're all joining up together to create I again. Okay? Now let's identify the direction that we're going to be walking. Okay? So I'm guessing that we are going to be walking counterclockwise there. And if we do this loop, it'd be same direction. So I like to be consistent. All right. Let's pick a starting point and let's start counting. Okay. Again, I1 is traveling to the right here. All right. I is traveling up here. And if we wanted to, let's go ahead and just draw I traveling down here. Okay, so basically this lower loop only has two currents, I and I1. Okay. Okay. So, and again, we've said that we're going to be walking clockwise around this. Okay. So let's go ahead and draw our equations down below. All right. Pause the videos, and if you haven't drawn those equations, go ahead and try it. Okay. Well, let's try it now. So let's choose our starting point here. And we're going to walk to the left, and this battery is pointed to the left. The positive terminal is on the left, the negative terminal is on the right. So that battery is pointed to the left in the same direction that we're pointed. So that's going to be 12 volts, right? I'm going to leave a little bit of space between that and the equal sign because I do have another battery that I have to work with. Okay? So now I'm going to be walking up. And now I'm going to be walking to the right, and I'm walking in the same direction as I1 across that 2 ohm resistor. So that's going to be positive 2 ohms I1. And I'm going to continue moving to the right in the same direction that I1 is pointed across that 4 ohm resistor. So that's going to be positive 4 ohms I1. Now I'm walking to the right, but the 6-volt battery is pointed to the left. So that is minus 6 volts right there. Okay. Let's just, while we're here, let's practice the other equation. All right. Let's do the other loop. This is going to be I2 traveling to the right. And that's also I2 traveling down. I2. We'll finish sorry, I don't like that got turned automatically to green. So we'll finish the problem on the next page. Right now we're writing just our equations. Okay, so I2 is pointed to the right across that 4 ohm resistor, and it's going to be pointed going down right there. And again, we're just doing this top loop. Okay, just with this and what we've done here, we can solve the problem with just that. But I want to do the whole thing, and I want to do it right. Okay? We've determined that I1 is going to be pointed to the right. And to be consistent, I'm going to also say that we are going to be moving clockwise in this loop. And we'll call this loop A, and this is loop B. So this is loop A. Loop B. So loop A is the left-hand equation. Loop B is the right-hand equation. Let's pick a starting point. I'm going to start right here. We're going to be moving to the right in the same direction that that I2 is traveling across the 4 ohm resistor. So that's going to be 4 ohms I2. Now we're traveling down. Now we're going to be traveling to the left, and even though I2 is to the right, we're traveling left in the same direction that the 6-volt battery is pointed. So that's going to be positive 6 volts. Okay? Batteries, we're thinking about the direction that the battery is pointed and the direction that we're pointed. With resistors, we're considering the direction that the current is pointed versus the direction that we are moving. Okay? And I'll show you in a second here. Now we're on I1, and I1 is pointed to the right, and we are moving to the left across this 4 ohm resistor, so it's going to be negative 4 ohms I1. And again, we're moving to the left across that 2 ohm resistor, but I1 is pointed to the right, so that is going to be the equation for the B loop. Okay? On the next page, right here, it looks like I've switched it up a little bit, but I'll say this. Let's just say that we are traveling, forget about this, we're being consistent in the way that we did it before. So this is going to be negative, this is going to be negative, and this is going to be positive. Okay? So adding these two equations together, you actually get the outside loop, which we determined earlier. 12 volts is equal to 4I2. And so 12 volts divided by 4 ohms is going to be 3 amps. So we know this is 3 amps. And we did it right here. Okay? And so now that we know that that is 3 amps, that I2 is 3 amps, we could plug that into this equation and actually solve for the problem. Actually, let's use this really easily. We could actually use this to find out what I1 is. 12 volts minus 6 volts. Let me rewrite that. 12 volts minus 6 volts is equal to 2I1 plus 4I1 is going to be 6I1. So that's going to be 6 volts equals 6I1. And so what that is going to work out to be is equal to 1 amp. Okay. Well, I1, using this junction rule right here, I is coming in, I1 is traveling to the right, I2 is traveling to the right. So I is coming in, you got I1, which is 1 amp, plus 3 amps, that's going to be equal to 4 amps. So that means this is 4 amps going across this. Okay? We can somewhat merge the two methods together in a hack. And this seems to work consistently for me. It gets a little difficult if there's more than 2 resistors in one loop. So let me show you this, okay? And this is a way to momentarily combine resistors and batteries together so that you could solve a problem, okay? So here we go. We're going to just look at this loop A right here. And this is loop A, okay? So we're just going to take this part and we're actually going to redraw it, okay? We're going to restructure this circuit, this loop, so that we could merge the two methods together, okay? So you have, let me go ahead and draw the currents again to remind us what's going on with this guy. So we know that I is traveling up. And then we also know that I1 is traveling to the right across all of that. Okay? So there's something that we could do. We could actually move this battery around to be on the bottom. And then once they're together, you could, if they're pointed in the same direction, they would add voltages. And if they're pointed in opposite directions, you'd subtract the voltages. Okay, so let's take this guy, and I'm going to bring it, and I'm going to, it's pointed to the left, right here. If I slide it along this wire, well, now it would appear, I'm going to go ahead and draw this. Now, if I slid this to the left, to the right, now on this wire, it would be pointed up. And then if I continue to slide this down, it would be pointed in this direction, right? So I'm just taking this guy and sliding it here. Another thing is you could slide it here and keep sliding it here. If we did that, it would be pointed down, and then keep sliding it here, it'd be pointed to the right, and then slid it over here, and it'll be still pointed to the right. So you could do this where you're kind of moving the battery around on the wires, but keep it pointed in the direction that it's pointed relative to the direction to the wire. So now you've got a battery that is pointed to the left. You got a 12-volt battery pointed to the left, and you have a 6-volt battery pointed to the right. Well, if they're pointed in opposite directions, you got 12 volts minus 6 volts. That's just going to combine those two together, and that's just going to be 6 volts, right? Right? So you combine those two together, and it's just 6 volts. And this is going to be E1 plus E2, right? I mean, E1 minus E2. So you could also, while you're here, combine the two resistors together. You got two resistors in series. That's the equivalent resistance of just one resistor would be R1 plus R2, which is going to be 6 ohms. Well, now this is an easy problem. 6 volts here, 6 volts here, 6 volts divided by 6 ohms, 1 amp. Easy. And so using this method right here, well, now you've just got this one resistor at the top, 4 ohms, and you've combined these two resistors together into a 6 ohm resistor, and you've combined these two batteries together into a 6-volt battery. Well, 6 volts here, 6 volts here, 6 volts here, 6 volts divided by 4 ohms, 3 amps. 6 volts divided by 6 ohms, 1 amp, right? So 3 amps traveling up, 1 amp traveling to the right. That means there has to be 4 amps traveling in, and that means this is 4 amps. So I guess what I'm saying is you could use multiple methods to do all of these problems, okay? And you can actually combine methods together. So what I want you to do is I want you to go ahead and try the traditional method of doing Kirchhoff and Ohm's law and see what you get, okay? Try it out, do your best. Again, with those lecture tutorials, you have to get whole numbers. And there's only I think 2 major problems, and I have it chopped up so that you could show your work. So go ahead and try it. Okay, good luck. I hope you have fun doing it.